welcome back to another session on my YouTube channel. So today we're going to be considering theorems in Laplace transformation. So they are basically theorems we can actually use just like we derived some basic standard solutions to any Laplace problem. So there are also theorems in which we can apply to make Laplace workings easier for us to solve. So today we're going to be considering now the first theorem, which is called the first shift theorem. So our first theorem is called the first shift theorem. So our first theorem is called the first shift theorem, which states that if the Laplace of a function of t, we all know that the Laplace of every function of t is equal to the integral coming from 0 to infinity of function of minus st times the function of t dt will eventually give us a function of s, right? On all our derivations of our previous video, we're always getting a function of s, right? So if the Laplace of function of t is giving us a function of s, then the first shift theorem says then the Laplace of exponential minus at of the function of t will give us the function of s plus a. So this is basically all what the theorem is trying to talk about, that if the Laplace of a function of t will give us a function of s, then the Laplace of adding another function of t, that's exponential minus at, to this function of t will give us a function of s plus a. So now let's prove this. So if the Laplace of a function of t, which is equal to the integral coming from 0 to infinity of exponential minus st function of t, then let's express this as we express this. Let's express this also. So that means Laplace of exponential minus at of a function of t will be equal to the integral coming from 0 to infinity, right, of exponential minus st. Now we have two functions of t, right? So we're going to write both of them times exponential minus at ft dt, right? So now let's apply our rule of exponential function. Now we're having exponential of minus st and we're having exponential of minus at. You know that when two exponentials are multiplying to each other, there's going to be an addition sign. So we'll be having integral coming from 0 to infinity of exponential minus st plus minus at function of t dt, right? So plus minus is minus, right? So we're going to factor out the minus sign. So now let's continue from where we stop. So plus minus is going to give us minus, right? So we're having integral coming from 0 to infinity, right, of exponential minus st minus at f function of t dt. So now let's factor out the minus sign. So factoring out the minus sign, we'll be having integral coming from 0 to infinity exponential minus s. Now if I factor out the minus sign, I factor out t, because t is here and t is here also, and minus will be a minus. So factoring out minus sign, so we'll be having a bracket of s, factoring out t also. So eventually this gives me plus t of function of t dt. So now let us compare and see. Remember our theorem says the Laplace of exponential minus at of a function of t is going to give us this, right? So now, and we said since the Laplace of function of t is equal to integral coming from 0 to infinity of exponential minus st of function of t dt, and this eventually will give us a function of s, right? Because there's an s here, let's assume, because there's an s here. So if this is giving us a function of s because of this s here, then the Laplace of exponential minus st of times f times function of t, which is integral, comparing this to this, you see that the only difference is that this here is a function of s, while this here is a function of x plus a. So which proves the fact that our answer is having a function of s plus a. So the shift theorem says if the Laplace of a function of t, which is this, will give us a function of s, then the Laplace of a function of the Laplace of the exponential of minus, now a is a constant, right, times t times a function of t, a different function of t, will give us a function of s plus a. So now let's take an example. You see how it is being worked out. So Now let's take an example. So now if you can recall our previous video, we treated how to calculate the Laplace of a sine function. So now they said find the Laplace of sine 2t. Now we all know that the Laplace of a sine function is equal to a divided by s squared plus a squared. Now this is Laplace of a sine function where a is a constant, right? So we're having a constant here which is 2. So definitely the Laplace of sine 2t is equal to Laplace of sine 2t is equal to 2 divided by s plus 4. Now we are going to apply our shift theorem. Now the second question says find the Laplace of exponential minus 2t sine 2t. Now since we have calculated the Laplace of sine 2t, now let's assume sine 2t is the function of t and we have the exponential function here. We can call our shift theorem. Our shift theorem says that the Laplace of exponential minus at of function of t times function of t is equal to, will give us a function of s plus a. Now if we can compare this with this is my exponential function and this is my function of t. So now if the Laplace of a function of t is giving us a function of s, and the Laplace of, when I add the exponential function, will give us the function of s plus a. So that means we can just easily get our answer. So now since this is a function of s, right? This is a function of s, a function of t. Now we're looking for the function of exponential minus 2t sine 2t. So solving this is very easy. We all know that the answer we're going to get will be a function of s plus a. So all we need to do is after getting the Laplace of a function of t, we just substitute the answer for s plus a. Very simple. So that means the Laplace of exponential minus 2t sine 2t, since the Laplace of the function of t is giving us a function of s, then the Laplace of the exponential function is giving us a function of s plus a. So all we need to do is, since this is the function of s, all we need to do is substitute our s for s plus a. So that means since this is the answer for the Laplace of sine 2t, our answer will be 2 divided by, now what is the a here? My a is what? Now comparing this to this, my a is 2, right? So this is substituting x plus 2, we having x plus 2 raised to power 2 plus 4. So thank you guys for watching. Please subscribe.